D-Wave claims they have achieved quantum supremacy for the first time,
How much is time worth?
performing actual useful computations that would take classical computers more than 1,000,000 years in minutes. D-Wave just reported a 509% jump in their quarterly revenue selling quantum computing services and computers, and that resulted in almost doubling their stock in days. This new quantum computer will revolutionize fields such as AI training and inference, business operations and logistics optimization, medical devices, ultra-precise sensors, material science, and more. So, what is this and how is this different from Microsoft Majorana 1 and Google Willow that they just announced recently? Although both Majorana and Willow are research breakthroughs, D-Wave Advantage, which is the name of the quantum computer, uses a different approach and falls in a different category of quantum computers. What Google and Microsoft are working on is called Universal Gate Model Quantum Computing, which, as the name suggests, is a more generalized approach and might be a decade or more away from commercial use. What D-Wave has been working on for more than a decade and is now commercially available is quantum annealing. This category of quantum computing is particularly useful in two areas of optimization algorithms and probabilistic sampling, which have a lot of very interesting use cases. So just briefly explaining what quantum annealing is. First of all, my understanding of this is very shallow and basic, so this is just a very high-level explanation. If you've ever seen people working with metal or glass, you see them raise the temperature and then allow the material to cool down to a stable state. That's called annealing. In quantum annealing, the machine has a bunch of qubits. In the case of D-Wave Advantage, about 5,000 of them. These qubits are in their superposition state, meaning we don't know what is their exact value. This is the equivalent of the hot metal. Then they use magnetic fields to gradually move the system into a more stable state, like cooling the metal down, revealing the actual ones and zeros. And because physical systems tend to move into the lowest energy state, the final product reveals the answer to the lowest energy state variables. They run the experiment a couple of times to reduce noise, and that's how they reach an optimal solution for a problem. How does this compare to the universal gate model quantum computing? If you imagine in a gate model quantum computing, we are trying to control a quantum system to perform computations for us, which is extremely difficult and intricate. In quantum annealing, we are setting the system up in a way that the final output is our desired solution. But we are not controlling the system. We are letting the system go through its natural path and reveal the final answer. What's particularly amazing about D-Wave is that they have been talking about their new computer for a while now, and no one cared or probably didn't believe them. But with the 509% quarterly jump in their revenue, it became suddenly real. They have a bunch of customers, but perhaps the most notable purchase is Jülich Supercomputing Center in Germany. While we don't have the exact number, they have paid somewhere between $20 to $40 million for one Advantage quantum computer. And they are working on pairing it with their own Jupyter supercomputer, which is the only exascale high-performance computing system in the entire Europe. And the pairing will be used to, quote, facilitate breakthroughs in artificial intelligence and quantum optimization applications. This pairing is a first-of-kind opportunity for tackling the world's toughest computational problems. I'm actually not sure if the current algorithms are suitable for quantum computers, but optimization and probabilistic sampling are core to AI. And if any practical algorithm could utilize the quantum annealing properties, we have no idea what would come out of that. The quantum computer not only performs computations that would take classical computers millions of years in minutes, it also consumes far less energy. D-Wave not only performed a simulation of a set of magnetic materials that would take the fastest supercomputer on Earth well over 1,000,000 years, but it also used 12 kilobytes of energy, while the supercomputer would have used more than the global annual energy consumption to perform the task. Other than selling supercomputers, D-Wave is now making the Advantage quantum computer available on the cloud to national labs and companies all around the world to perform their tasks online. For example, simulating magnetic materials gives companies the ability to perform digital experiments instead of long cycles of real-world testing. Ford Otosan, a joint venture between Ford and a Turkish manufacturing company, are using D-Wave to optimize automotive assembly.
Let's go ahead and make this problem a little bit more tricky. So I'm going to take this up to this 350 vehicle scale, and I'm going to go ahead and kick off a run of our hybrid solver. So at this 350 vehicle scale, things start to get really complicated. Different vehicle combinations have different amounts of effort that go into it. And so here I show a comparison between a solution that's found classically using a greedy approach, and you see this big, long spike in the top and this big, long trough at the end. Whereas our solution was able to find a nice even as it's possible, a nice even sort of work gradient, so where it's averaged over those last 20 vehicles.
Boeing is using the quantum computer to build a more robust assembly operation for planes with more than 1 million individual parts. There are food deliveries and cell tower companies trying to optimize their locations and operations. And this is the first time a quantum computing platform is available for them to use.
You're in a food company's business now, helping them with logistics, but why can't AI do logistics work just as well?
Typically, we end up being used to solve problems that are very, very hard to solve classically. A problem known as the traveling salesperson problem. You want to start at one city, you want to visit a set of other cities to sell your wares, and you want to find the shortest path to visit those cities. That's what's known as an exponentially hard problem. What that means is that the amount of computation required to solve that problem grows exponentially, very, very fast with the size of the problem. Classical computers cannot keep up with that. AI today runs on classical computers. There's just no way to perform that computation efficiently on classical computers, and that's where quantum computing comes in.
So what happens from here? D-Wave has a roadmap to increase connectivity and coherence in each generation, with the stated goal of achieving 100,000 qubits by 2030. They are already at Advantage 2, and the use case we are most interested in, AI training and inference on a quantum computer, falls somewhere in between 2027 and 2028, about 2 years from now. AI trained on a quantum computer. I honestly have no idea what to expect of that. Unattainable amount of compute for any classical computer, while being more than 1,000x more energy efficient. To summarize at the end, D-Wave has made the first commercially available quantum computer. It's not as general as quantum computers of Microsoft and Google, but it is useful and practical now. And it has a lot of implications in the near future to work alongside classical computers in AI and material science and ultra-sensitive sensors and a lot of other fields. Hope you have a nice day. See you in the next one.